But I only... Okay, never mind. Man, I got a headache. Hi, I'm Jeremy Engelman, and today we're going to be talking about lighting effects in Maya. And we're going to start out by talking about mapping a light's color. Mapping a light's color is incredibly useful for simulating a more natural kind of light than Maya's computer kind of even, perfect method of illumination. But it can also be used for mapping very complicated types of light, like firelight or even caustics. And simulating caustics with this method is very important because even if you're able to calculate caustics, it's not necessarily always a good idea because they're very expensive to calculate and they can so easily be faked. And then we're going to talk about optical effects. And optical effects are a phenomenon of looking through a camera lens at a bright light source. When you do this, you will see anything from, or at least I see, anything from stars and rims and halos and lens flares. And these don't actually exist in the world. They are a result of the lens itself. They're an aberration of the lens. So, relating to that, we're going to talk about shader glow. And shader glow is a way for you to simulate optical effects off of a surface. And if specularity is reflection of light source, if that light source is bright enough to produce an optical effect, then the reflection of that light source would also be bright enough to produce an optical effect. So in order to do this, you would use shader glow. So we have a lot to talk about, and let's go. Let's start out with a super simple case in which you'd want to map a light's color. Well, when would you want to do that? Well, in this case, we have a little guy on a street, and he's carrying a flashlight illuminating the side of this building here. So, if we render this, we'll see that I've already designed this light to have about the right cone angle, to have a penumbra and a drop-off that, seem appropriate for a flashlight, for this kind of a light this guy might be holding. But what you can see is that the interior, there is no interior detail. It's a perfectly illuminated white area on this wall here. And you should know that flashlights have interior details. They have a housing, they have reflectors, they have a bulb in there. It's very complicated, the actual light that they cast. It's not this perfectly even computer graphic white light circle. So what better way to mimic the detail that a flashlight would have than to use the actual image from a flashlight? And so what we've done here is taken some images of different mag lights. We just took the flashlight, pointed it, held it up to a sheet or a piece of paper, anything like that, and then took a picture of the other side of it. So you can see how different lights will actually look. And so what you want to do is you just want to take one of these and map that file to that light's color, and you'll begin to get a more realistic illumination of a flashlight. So I saved one of these out, and if we keep this image so that we can compare, and we do an IPR render of this image, pick our area to tune, and we'll go ahead and pick that light, the light shape, and we click the map button next to the color of that light. Map it with a file, and I've called this mag light, and there you can see the image. And here in the IPR you can see now we're starting to get an image that looks more like an actual flashlight and not a computer simulation of a light. But there's still some more work to do because, as you can see, now that we've mapped that with a color, we have lost some of the value in there because it goes from lights to darks. We've lost a lot of the value in there. We've lost some of the cone angle because it fades out a little quicker. And if we want to retain about the same amount of illumination, we'd have to go back to here and possibly increase the intensity and increase maybe the cone angle, and we can start to get back about the same area of what we had. But this light now might be a little too sharp. The light would defocus as it travels from the flashlight itself to hit the wall, so we may need to blur that a little bit. So you can use Maya's blur on file textures here in the form of this filter offset, and you want to use very small numbers in this filter offset because even a number like 0.1 may blur it too much. So I'm going to use a number like something like 0.05. Now we have some detail, this interior detail of this light, and it's starting to look a lot more like an actual flashlight would. So if then we keep this image and we compare these two, we're seeing the difference is subtle, but it does read. It reads more like a flashlight than the other one did with its perfect circle of illumination. We have this interior detail here, and all we had to do is map the light's color. We have another example here of where we've already mapped the light's color. And you can use mapping a light's color to not only simulate something very particular like the flashlight, something that has a known look to it, but also in this case we have mapped the light's color purely to create some extra visual interest to this scene, to this image. So if we render this and then keep that, and then I come in here and disconnect all of the lights where we've mapped the color, and re-render, and then we compare these two images, clearly one is more interesting than the other. This is just pure Maya lights with no color map to them, and you've got that characteristic very graphic, computer graphics feel. All of the lights are these very distinct areas that have no actual interior detail or interest at all. We come back to the original one, and it's just a much more interesting image. There's the world is so complex, and the way light interacts is so with each other is so complex that very oftentimes purely mapping the light color will give the impression that there is much more going on in the scene than just a couple of perfect lights pointed at this subject. This may indicate that there are some rafters up here or something in the way of the lights casting these shadows here, and that there's some color here. It just makes for a much more interesting image than this one. Now, mapping your lighting color is great because it allows you with one simple change to completely change the look and the mood of your imagery. So if we have our old render here, we can see we've got this cool blue light coming from back here. But if we change what's mapped to this light, break the connection, map it with a file this time, we map it with this full frame fire, you can see that clearly it's changed the mood of our render here. I'm going to go ahead and blur that a little bit. And we've got something completely different now. The other cool thing that you can do with it is that you can use an image sequence for mapping your light's color. And in order to do that, you just click the Use Frame Extension checkbox and set a key, come out to a different frame, change the value, and set another key. And you can see that our frame extension is now changing with our frame. But if you come out here past 30, you'll see, well, it doesn't update anymore. So a better way to do this would be to break this connection and then create an expression. And the expression editor will come up with the right attribute selected. We want to create an expression for file 2's frame extension. So we copy that out of there, paste it into here, set that equal to frame with a semicolon, don't forget the semicolon, create it, and close. And now you'll see that our frame extension will always be equal to our frame number. And you have to be careful and make sure that your sequence is long enough, because you'll see here we don't have 94 frames of that sequence. So you have to make sure that your sequences are long enough to support the animation that you want to render. And another cool thing you can do is use the script Render Window Plus, and that script is available from highend3d.com. You can download it and use it, and that adds some additional functionality to your render view. You can see there's some additional buttons here, which are handy. It allows you to preview individual channels as opposed to just R&B or alpha. So that can be useful. But what it also allows you to do is to render within the render view and save it out to a file a sequence of images. Now that's good because it, as opposed to batch rendering, it doesn't launch a separate copy of Maya, and so you can save some memory doing that. It's just much more efficient. So in order to do that, you're going to pick a region, render that. Pick the region, get that region rendered. Make sure that your render globals are set up to render a sequence. And we'll render 10 frames of it, frame padding 4, and then click the Render Region Sequence. And that's nice because, again, as I said, it allows you to render just a particular region of interest. You don't have to render the entire frame. So in this case, if you only want to preview the effect of your color map image sequence, you're not having to render the entire frame. And once that finishes, you can come out to F-check, and you can see the result of your color mapped image sequence. So where can you get these images to map to your light color? Well, you can, of course, go out and shoot your own footage on DV Cam or whatever and digitize that and bring that in as frames. Or you could even shoot it on your digital camera, which many of digital cameras will allow you to shoot a small QuickTime or AVI. And you can use those to map your light color, because generally when you're mapping your light color you're going to blur it all out anyway, so you don't need particularly high resolution, particularly high frame rate images to map to this light color. You can get away with mapping it to mapping a digital camera movie from it. It's fine for doing that. Or you can go out to the old trusty internet, and there's any number of image libraries available to you online, which you can buy. Artbeats is a particularly good one. They have a ton of image libraries which you can purchase and use. So if you're looking for something like fire, you just enter your keyword here, and you'll see that they have a bunch of clips here with fire in them, but they also have pre-built libraries here, pre-made libraries that they sell of flames, which you can use to simulate a fire. Now here, these ones are perfect, like this, and you can even get a QuickTime preview online of this movie here, and you can buy this thing by itself, or you can buy it in the library. So any one of these places is perfect for getting some of these image sequences to map to your light color. And here we have several here which we bought, and you can use this. This one is particularly good because it's fire and it encompasses the entire frame, so you get very little black. That one's great to simulate firelight. And you have some of these other ones here. Digital Moods is an image library you can purchase, and there's any number of sequences that you can use to map the light color. And you can use this one for, anything from simulating caustics, or just increasing the depth and interest of your lighting, and having this color and this motion in there. You can use it to render out something that looks something like music videos, or using it to simulate something like a spell, some wizard casting or whatever. But imagine how cool some of these would look mapped to your light color. And some of these are really subtle, so you don't have to have anything as big as a fire or a some explosion or anything. You don't have to have it that big a reason to map the light color. Any one of these would just increase the visual interest of your imagery, of your scene. And this would be really interesting. Just obviously some golden light from the sun, or some rays coming out of something else. But again, it's nice and soft and subtle, and you can really use it to add a lot of depth and character to your rendering. So now we're going to get this goat, and he's alone. He's all alone. But let's say we want him to be alone by a fire. And so you'll want to, map your light color with imagery from a fire. So if we create a spotlight, look through it, and get our settings a little better, we'll cast shadows from this light, blur those a little bit, close, we get back to perspective, and look at our light again, and we want to map the color of that light. So we'll map it with this image sequence here of full frame fire, and we will use frame extension. We'll create our expression for it, file one frame extension, paste it in there, equals frame, semicolon, create it, and we'll set our frame ranges to 30, because that's all the frames we have, and you'll see our frame extension is updating correctly. So now, if we do an IPR render of this goat sitting next to the fire, you can see that a lot of times it's not enough to simply map the light with a file for the color, because this doesn't really look anything like fire, because fire light doesn't cast perfect strands of fire into the environment. It just casts this general look, these general colors, and the amount of flickering. So what we want to do is we'll have to raise our intensity some, because now that we mapped the color, it's taking out a lot of intensity. And then what we want to do is we'll want to blur this so that we're just getting the idea of that fire. So you can use the Maya blur, the filter offset here, but I find what starts to happen is when you begin to blur it more and more, you start getting this very blocky kind of blur happening, and that's just due to the way in which Maya is blurring. I would prefer to blur this fire with a Gaussian blur, like from Photoshop or Shake or After Effects. You can use any compositing package to blur these images, this whole sequence of images, but if you only have access to Photoshop, you can use that too. So if you come out to Photoshop and open one of these, you can record an action that will perform your blur on the entire sequence. So if we go to the Actions palette and create a new action, and we'll call it Blur, simple, and we'll be recording the action now. We just go to Blur, Gaussian Blur, and you want to blur it quite a bit. Don't be shy on this blur, because you just want the idea of fire. You want the color, you want the amount of flicker, you want the variation in the sequence, but you don't want it to look as though fire was projected through a light. It will be a lot softer than that. So you can use pretty high numbers on this blur. Hit OK and stop recording your action. Now you have this action on that you can then use on an entire folder of images. And we'll close this, say no, because we don't want to blur this multiple times, this first frame of this image. And then you come down here to the Automate menu, Batch, and you choose that folder of images that you want to blur, but be sure you copy it out to another folder so that you're not blurring your original images, because you'll wreck them. So choose your duplicated folder, save and close is the destination, and then just click OK. And then Photoshop will go through all of the images in that folder, blur them so that you'll have a blurred image sequence. It's pretty fast. So come back to Maya, and since this is the image that I've already chosen, take the filter offset back off and reload this file texture. You'll see that I'm getting now my blurry sequence, which again will be much better for simulating the look of fire. And the overall lighting that a firelight would produce. So now using Render Window Plus, I rendered out a image sequence of the result. And we come out here to F-check, open the animation, and I called it goat fire. We can see our goat standing here alone by a fire. So what else is mapping light color good for besides goats and fire and music videos? Well, it's great for faking caustics. And what are caustics? Well, caustics is simply a refocusing of light as it passes through something, a transparent medium of some kind. So as light passes through things like water or glass. It will refocus, and you'll see spots, areas of illumination on the far side of it. So here, in this case, in this underwater scene, you would expect this light coming through here to refocus in that water pattern that you're accustomed to seeing if you looking through down the bottom of a swimming pool or lake, whatever. You'll see this refocused light here on this dolphin's back and along the ground. So if we do an IPR render of this scene, you'll see that we've got our dolphin underwater here, and along the floor, the ocean floor, you'll see this caustic effect. So if we tune this, and if we take this light and then we break the connection because we're mapping the color to a caustic image, you'll see that, one, we're not getting the light color as we were, but also we're not getting this pattern of illumination along the ground, which we should be. So it doesn't necessarily look like he's underwater anymore, which clearly we need him to be. So what we're doing is we're mapping this light color to an image sequence of caustics. And as it updates, you'll see no caustics here. So if we come out to F-check and we look at the sequence that we are using to map that light color, we're using water caustics, and there it is. This is a simple image sequence of this light refocused pattern here. You can see as light passes through that surface of the water, the waves, it gets bent and then refocuses. You get these characteristic patterns. So then if we look at our rendered image of that dolphin, we can see that as he swims through here, we get our light creating these caustic effects down here on the base of the ocean floor and along the dolphin's back, which helps to plan it, which helps to make you believe that yes, we are in fact underwater looking at this dolphin. And remember to use IPR when you're tuning this, because mapping light color clearly obeys and is updated by IPR. So again, save yourself time when you're mapping your light color and do IPR renders and update that way, because doing re-renders, you're just going to be wasting a bunch of time. So that if we, now go ahead and map this with some other type of image, we break this connection, and then we map this with some other caustic imagery, like this one. There's a whole range of different kinds of caustics that you can use. So if we map with this, we'll get a whole different look to this underwater scene. And mapping the light color, you can also change the number of repeats. There is a place 2D texture node, just like with any file texture, so any of this stuff is obeyed by mapping the light color. So if you need it to repeat more, clearly you can just change the repeats in here. You need to rotate it some, you're not liking the particular orientation of the stuff you're looking at, you can go ahead, and of course then you can animate any one of these as well, so that if you wanted to animate the rotation of this caustic image, you could, and that would be a simple way to have your caustics and your rays move around on the environment. So these place 2D texture nodes, you can use those as well, and you can animate these parameters as well. Now let's talk about optical effects. Now, what are optical effects? Well, simply put, they are something that happens when you're looking at a light as a result of the lens that you're looking through. Optical effects don't actually exist in the real world. They're purely an effect of the lens through which you're looking. So your eyes are lenses, so you do experience optical effects from your eyes. Anything like lens flares or halos or star points, any of these kinds of things is an optical effect. And these are rendered as a 2D post-process in Maya, so you have to be careful when IPR tuning them. If you select a region that's too small, it may not come out correctly. But generally, they are IPR tunable, and that is the best way to do them. So the thing to remember about optical effects is, again, they are an effect of the lens through which you're looking. So they don't exist. So if the way you can test if something is an optical effect or not is, put your hand in front of it. If it goes away, it's an optical effect. It's not really there. So as you can see, there's a whole bunch of different kinds of optical effects here. You have stars, you have lens flares, you have rings and halos, and all kinds of things. Now, what's interesting here is these are all point lights in Maya, and they are all identical types of point lights. A point light with an intensity of 10. Each one of these is a point light with intensity of 10, but they have a different optical effect mapped to them. You find the optical effects in the light effects rollout, and it's under light glow. So if you were to create one, you would click this button here. This one already has one created, so you can go to it by clicking that. Now, this particular one, if we pick a region to tune, we can see that the light that we have selected is this one in the far corner. So we'll be adjusting this one here, and we can adjust the number of star points. And you can see it updating. The important thing about star points to realize is that Maya does allow you a decimal number, but what you want to use is an integer number, because here you're getting 0.785 of a star point, and that isn't something that you would see in the real world. You wouldn't ever get 0.785 of a star point, so you want to keep this number some kind of integer number. But optical effects has tons of tweakable parameters. Clearly, you can get a wide variety of optical effects with the same exact kind of light. What you want to do, though, is remember that if these are genuinely the same kind of the exact same light, if you're trying to simulate that they are the same light, you don't want to have a different optical effect on them. Because while this is cool that you can have such variety, if it is the same kind of light being looked at through the same lens, the same exact lens, you would technically, in reality, have the same optical effect. Because again, it is an effect of the lens. So, at any rate, all of these parameters you can come in, and again, they update via IPR very quickly, so in designing your optical effect, IPR render, and you can see the result very quickly. And we can adjust any of these lights, of course, just by going to their optical effect node. And we've got we have a preview here by turning on the halo, changing the color, intensity, and the spread. You can design your optical effects this way. Now, what we'd like to do is look at a few examples and hopefully some practical uses of these things, because it can be pretty overwhelming to come in here and have all of these different parameters. They're mostly self-explanatory, but again, what we want to do is look at some examples of how you might accurately simulate a light glow, an optical effect that you would get in the actual real world. So now let's look at a practical application of our optical effects. I'm going to IPR render this scene. You can see we've got this barren landscape, and we will have, in just a minute, a moon in the sky, and for this moon we want to have an optical effect. So I'm going to pick a region to tune. I've IPR rendered this, and remember that optical effects do obey IPR, so you can tune them very quickly and easily. So, and I have a point light in the sky, which is going to represent our optical effect only light, and get the attribute editor up for that. And then in the light effects rollout here, we'll map the light glow. And this is how you get an optical effect. So in here you can see we've got a light glow here. It's not quite what we want, so we're just going to tune that. But here it's worth pointing out that in your glow type pull down here, there's several different types of glow you can add. But in the glow type lens flare attribute is actually misnamed. This is actually a spectral type. And the rim halo is also misnamed. It's actually a rainbow glow type. So these two are in fact misnamed. In the halo type, these are correct. But in the glow type, they're wrong. So, and it's also worth pointing out that the halo type lens flare will give you a lens flare, but that there are really no tunable attributes for it. So for doing lens flares, you'll want to check this button, which we're going to talk about in a little bit. So for right now, I want to go ahead and tune this to get it looking how I'd like for it to look. So I'm going to turn on a rim halo. I'm going to take off the star points here. I will open up the glow attributes folder so I can tune the glow. I'm going to take down the intensity. I'm going to make it a little bit bigger. I'm going to then open the halo attribute so I can adjust my halo here. I'm going to take down the intensity so we can start to see it. It's way too bright before. We've got something. And I'm going to make it a little bit bigger. So now what I'd like to do is, this being a moonscape, I want there to be some mist, kind of cloud layers in front. And you can fake this by adding some glow noise. And then opening the noise rollout here and adjusting the parameters. So you can see we've got some noise beginning to come in here, and I'm going to adjust the scale here so that you start to see it's got these kind of long, wispy kinds of layers happening. And I'll pull up the threshold a little bit so it's a little bit, you can see it a little bit better. But this is great for simulating, like I said, some kind of cloud or mist layer in front of this, but you should be aware that this behaves as a 2D noise. Optical effects are a 2D post-process, so it is only a 2D noise. So if you were to do something like a camera move on this noise, and your light was really close to the camera, that noise would sort of orbit around the camera, and it would look really unnatural. It's not a true 3D noise. So that if your light was very close to your camera, you probably couldn't get away with using this to simulate some kind of cloud or mist layer. But for a faraway light source like this moon and some faraway cloud layers, it works fine. So then if we do a final render of this, we can see that we've got everything coming together here and looking quite nice. So let's crack open this scene and talk a little bit more in depth about optical effects, because there's a few other situations in which you might want to use it, and there are, of course, a few hiccups that you'll encounter when using them. So for this scene here, we have simple landscape, we have a sun in the scene, and we'll want it to seem as though there is a sun here. And that's one thing that optical effects are useful for, is that making a light source visible that you wouldn't ordinarily see. Remember that in Maya, if you render this scene, you won't actually see any kind of light source. You'll see light coming from this light here. You'll see things being illuminated by it, but you won't see a source in the sky. And that's one thing that optical effects are great for, is making the light source visible. So if we render this scene now, we'll see our sky and our terrain and our little people here with their shadows here. And remember those shadows, because this will be important in a minute. And keep this image. Close that, and now if we want to add an optical effect to this light source, what do we do? Well, one problem is directional lights in Maya are not capable of producing optical effects. So what do? Well, one way in which you could get around this is by creating a point light and having this point light represent your optical effects. So what do you do then? You create lights, point light, and you could then take this point light and move it over to where your sun is, and in a scene of this density, that's going to be kind of difficult because it's very dense, very large. So you could futz around in here trying to move this point light to be in the same place as your sun. Or, if we delete that light, you can simply pick this light, duplicate it. We have another sun down here, attribute editor that, change that to a point light, and now we have a point light in the exact same place as our directional. But we don't want this point light to cast additional illumination into the scene, so we simply turn it off. Illuminates by default, we turn off. So that our sun, our directional light, is the only light casting illumination. The point light is off. The point light is going to serve as an optical effects only light. So we come down here to the light glow, map it, and we've got our optical effects. So that now, when I IPR render this, we'll get something that we can begin to tune. Pick our region. And then go ahead and, again, just begin to tune our light glow to what we like. So if we take the spread, we move that up, we can start to see the size coming in. We can increase the number of star points. So we're seeing all the stars here. Take down the star level maybe. Take down the intensity some. You can add some radial noise so that there's a little bit of difference between the points. And we're starting to get something that suggests that there is a sun back there. And now if I re-render this, the whole thing, you should probably notice that the shadows of our people have gone away. And that's a problem with optical effects, is that our directional light here, which is casting shadows via a shadow map, has got a particular resolution, and it's using autofocus, but we've disconnected it from the sky sphere so that the autofocus is sharper, so that it is focusing on the people. But now that we've created this optical effect, for some reason Maya will assume this optical effect in its autofocus calculation, because it is, after all, a sphere shape. So what you need to do is you need to break the link between your shadow casting light and the shape node of your optical effect. So if we break that link and then we re-render, we should see that our shadows have come back. So that's definitely something to be aware of when using optical effects and depth map autofocusing. If you're not using autofocusing, you shouldn't have a problem, because you are specifying exactly where the focus of your shadows should be. But do be careful of that. So now we've got the same result on our shadows, but we've also got our optical effect. So what else do we need for this image? Well, we might expect to see a lens flare in this. Now, what's a lens flare? Well, aside from being overused in computer graphics, a lens flare is a series of reflections off the lens and each lens element of the lens through which you're looking through the scene. So that if we come out here and look at some images of actual camera lenses, you will see that there are several elements within there, and that there's a reflection off each of those elements. So if we come to our scene and do an IPR render of it, and pick a region to tune. Get our optical effect light. In order to enable lens flares, all you do is check the checkbox, lens flare. Now, be careful when using too many lens flares, because, as I said, it's something that was overused in computer graphics. People sort of started adding them all over the place because it tended to, it looked cool, and they're cool, and tended to make their images sort of stand out and look real and whatnot. But in fact, actual cinematographers for live action footage go through a lot of trouble to reduce the amount of lens flares, because it tends to be something that gives away that you're looking through a camera at what you're looking at, as opposed to participating in it. So lens flares are something that, again, tend to get overused. You should minimize your use of them. But in a scene like this, where you're looking off into the sun, you actually, in this case, you would expect to see a lens flare, and it does seem to be missing something without it. So in this case, it would be great to use, but you'll notice that Maya, by default, for some strange reason, the lens flare is going across the top of the image here. That's because our light is over here, and in the lens flare attributes, the flare vertical and flare horizontal numbers are set to 1, which indicates that that lens flare is going to move through the upper right-hand corner of the image. What you want is for your flare vertical and flare horizontal to be set to 0, because in actuality a lens flare is always going to move through the center of the image. And if you think about it logically, reflections off a lens you would think would be focused in through the center. So now that we have it happening a little closer to how it should be happening, you can start to tune your lens flare. And you can, again, tune the number of circles, which this is actually corresponding to the number of elements within the lens that you're looking through. So again, you would probably want to stay away from these fractional numbers and use integer numbers for this. But other than that, you have a size range here, min and max size of your lens flares. If you're trying to match some practical footage, you may want to know something about the lens that was used to film it, because these are all reflections off the number of elements in a lens, and if they're using a certain lens to film through it, it has a certain number of elements, you'll want to match that. And you'll also want to know something about the aperture of the lens that was used, because if it's a large aperture, you will get circular lens flares. If it's a small aperture, you'll get hexagonal lens flares. And you can see this by, again, looking at these images of lenses here. And a wide aperture, you'll see, takes on the shape of a circle. The small aperture take on the shape of a hexagon. And these are the blades of the iris that open and close to allow light through. So a small aperture will yield hexagons, large one will yield circles. So again, you'll want to, if you're trying to match something, you'll want to know something about the camera and the aperture at which they filmed it. And you can add a color to it. And the color spread will only have any effect if you have an actual color. If you've mapped the color of your lens flare, you can now use color spread. And it will basically, if you have a color spread of 0, there will be no color spread. But as you move that up, you will get a variance in hue among each of the lens elements. So again, it's best to, if you're trying to match, it's best to look at actual lens flares from that camera which you're trying to match, because otherwise you may have, a viewer may, it may be a subtle thing, but they may detect that something does not look the same to them, and it may stand out as being computer graphicsy. Now the flare focus, again, that will sharpen or defocus your lens, the elements. So again, you really want to be sure, if you are trying to match, that you look at flares from the camera you're trying to match. So if we do a final render of that, you can start to see that we've dealt with some of the issues with optical effects. We've got our shadows back. We've got our flare happening. We have the suggestion of a bright light in that sky, which without it seems empty. And it adds a lot visually to this scene. Now we need to talk about an optical effect's occlusion. In other words, how does it go away when it goes behind objects or objects pass in front of it? Well, the occlusion of an optical effect is determined by this sphere shape in the case of a point light, or a disc shape in the case of a spotlight. So when I render this, as you can see, the optical effect is full-on brightness, because this sphere is not occluded at all by any of the objects in front of it. As I move that light behind objects, that light and that sphere shape, you can see the optical effect starts to decrease in size and value. And your light behind here, your light can even be all the way behind the object, and you will still get an optical effect because this sphere shape here is still visible. So that if I move that optical effect all the way behind the sphere, I won't be getting it because this sphere shape is completely obscured by the sphere. So that if we needed the optical effect to fall off more quickly as it went behind the sphere, you can go ahead and scale the light and the sphere shape along with it, and it will diminish and go away much more rapidly as it goes behind the sphere. Now, in the case, as I've said, in the case of a point light, your sphere, you've got a sphere shape that's created, which determines the occlusion. But if you create a spotlight, and add optical effects to it, you'll see that now the occlusion is this disc shape. And again, simply by scaling this shape, you can determine how quickly your optical effects will fall off as they go behind other objects. A few other hiccups you're likely to run across when dealing with optical effects are related to mapping the light's color that's generating the optical effect, and then also in duplicating that light. So here we have a scene, nothing in it, but we have a light creating an optical effect. Now if we decide, well, we have this light that looks like it's supposed to be emanating blue and in all sorts of patterns and things, we want to map this light's color. So we will pick any one of these from the sequence, and we've got some color happening within this. So now if we re-render this, we're going to see, well, now we've got our color going on, but what happened to the optical effect? Well, one of the problems with optical effects is that the optical effect will take its color from the center of a color-mapped light's color. So this could be picking some very dark pixel within this image as the optical effect's color, and resulting in something that is not visible in terms of the optical effect. So in order to get it back, what you will want to do is create an optical effects only light. But you may be tempted to take this spotlight and duplicate it, and you will see that this spotlight, in duplicating it, your light glow from your original light is not maintained. It does not duplicate this stuff. It does duplicate the shape, but it doesn't duplicate the connections. So you have to be careful of that. Now, if we delete that light, and we take this light, and we then duplicate the input graph, and we have this spotlight, you'll see that now we do have an optical effects node associated with it. And then if we take that light again, and we break the connection to it, and we turn off illuminates by default, and then re-render, we will get the light creating the color and the light creating the optical effect, which is what we want. You may also then be tempted to take this light and change it to a point light. The problem with that is that it's going to maintain this disc shape, and all these connections are just all messed up in here. It does not work actually to create a point light from a spotlight that you already have an optical effect hooked into. It's a problem. So the best thing to do, again, is to take this original spotlight and duplicate it, maintaining the input graph. And then taking that light, breaking the connection on the color, because otherwise this new light will be taking its color from the center of the same image as the last light, resulting in the same problem, and then turning off illuminates by default. And you'll get what you want. You'll get what you expect. The optical effect and the color projecting through that light. Now here we have a scene in which we have a landscape, we have a sky, and we have a very reflective chrome ball. So if specularity is a reflection of light source, which it is, if that light source, in this case the sun, is bright enough to cast an optical effect, which it would, the sun in this case, it's a bright day outside, you would expect the sun to cast an optical effect, to have some kind of flare or glow associated with it. It's a very bright day, bright sun outside. In this case, we have a highly reflective sphere. The reflection of that light source would also create an optical effect on the lens itself. So, in this case, there are a couple of ways in which to get an optical effect happening on this sphere. One way, and it's the way in which you'd want to do optical effects for reflections of candles, for reflections of anything else that would have an optical effect, because optical effects don't actually reflect in Maya, so you have to duplicate them and then create another one to simulate the reflection of the optical effect. What you can do is you can create a point light, and you can position that point light around in front of the sphere here, where it might be casting that optical effect. And then you would, of course, turn off illuminates by default, do light effects, map the light glow, and then render. You'll be getting an optical effect from the reflection of the sun in this sphere. So you can see now we have an optical effect coming off of the sphere. But in this particular case, that maybe is not what you want to do, because if this sphere is moving, or if the light source is moving, or you would have to parent this light to it, and then if you were to look at it from a slightly different angle, you would see the optical effect in a different place. So this is really not the way to go about solving this problem. Again, if you were doing reflections of a candle in a mirror, that might be a better way to do it. But in this case, what you want to do is you want to use what's called shader glow. And shader glow in Maya is somewhat of a branch of optical effects. What that does is simulate optical effects coming off of a surface. So where you find that is in the special effects rollout of the material of the object. You'll see a glow intensity. And we can IPR preview our glow intensity, but since this sphere is ray traced, we need to turn off ray tracing in render globals so that we can IPR this to preview our glow intensity off this sphere. pick our region to tune. And then we can start pulling up the glow intensity. And then you can see we've got a glow coming off of this sphere. Well, generally what you want, this entire material is now glowing. And that isn't usually what you want. Usually what you want is for only the brightest point of this material to glow. And you may ask, where do you control the qualities of the shader glow? You control those from this single shader glow node in your scene. This is where you'll control the attributes of this glow, the color, the intensity, the spread, all of the same controls that you have available to you with optical effects are available in your glow types. But the one important one to watch is this threshold, because that will allow you to control where that glow comes off of. And in this case, we want it to come off only the brightest spots on our image here. And then you can see you can control the number of star points, just like you can with optical effects, their rotation. And so what you want to do is you want to make this match each other and any other light sources in the scene that would be having a similar type of glow. You want to make it match because, again, looking at it through the same lens, it should match your other optical effects. So if it has different rotations or different numbers of star points, something is wrong. So then, having this, being fairly satisfied with this glow, you can come back to globals, turn on ray tracing, and then re-render the scene, and you'll get your glow. And what you want to do, though, is you want to make sure that auto exposure is turned off. Because what can happen is, as it tries to automatically compensate for the glow intensity, you can get strange results. You can get that glow to pop, you can get it to sizzle as things come on and off the screen with different glows on. So in order to demonstrate that, I'll open F-Check here. I rendered out some animations. This one having auto exposure on, and you can see how the glow as it comes on the screen pops on and goes off, and it pops off. Now if I open the one with auto exposure off, you can see the glow and this glare fade on nicely and fade off. So be sure that you almost always use glow with auto exposure off. If you're rendering a still, it won't matter much. It's fine, because you'll only have a problem with this when you're trying to render an animation. Now I'd like to take a look at putting to practical use some of the things that we just talked about. So I have an existing scene here, which is a pretty simple scene. There is some simple geometry. It's textured, but again, it's quite simple. So if I render that, we'll see what we get. And I've already lit the scene with a few directional lights. So I have a moon and I have a few bounces. And you'll see, well, we've got some moonlight here, but there really isn't much going on in it. Nothing much interesting happening. So what I'd like to do is imagine that there is a fire, some kind of fire in this barrel here, like somebody's made a fire and this is going to be their home, these steps. So what I like to do is then unhide some lights. I've created 5 point lights here, and what I did is created them, basically within the barrel, but in sort of a pseudo-random configuration here, so that I get my light coming from a larger area than just a single point or a spotlight. So it's going to seem like this light is coming from this whole area here. But then again, I've just sort of distributed them a little bit in something that, you know, may look like flames. So distributed the lights a little bit. But the first thing I'm going to do with these lights now is I grab the first one and I'm going to map that light's color. So I map that to a file, pick it, and I'll just map this like that. And then from there, of course, I can, in the multi-lister, once it wakes up, I can grab my other lights and map those lights to the same file texture. And make sure they're all mapped. And you can see as I cycle through them, I have also different intensities on these lights, just again to break up, you know, the effect that they have. So the light isn't perfectly uniform within this volume here that I'm trying to simulate. So then if I render this, I'll see now I'm getting some of this additional illumination from these lights, from this fire that I'm going to set up in here. And I've got some illumination leaking through this garbage can, which I've punched some holes in, so I've got my illumination happening on the back wall here, and again I've got it spilling out into here. Now, I'm not able to see, there are a few holes here, again you can see the shadow from them, but you can't see the fire inside. So what I need to do then is take this little piece here of geometry that I put back there, and then I'm going to map this with the exact same image that I'm using for the light's color. But I'm also going to take that same map and map the incandescence. And I could do this by dragging it from the multi-lister as well, but for now I'll just do it this way. So I have the color and I have the incandescence mapped. That will give me something that self-illuminates so that looks like fire back there. And for this one, I'm going to go ahead and IPR render it. Because what I'm going to want to do with this is add some shader glow to this piece of geometry that's back there, so that we get these really glowing with illumination. I'm going to pick a region, and of course now you can see all of the holes that are punched in this bucket. Then I'll come down here, and glow intensity is in the special effects rollout, so I can just start by pulling this up and to a point that I like. So something like that, and we're really getting the sense that there is something really hot illuminating in there. Now for the last thing that I want to do to really push this image and push its lighting is I'm going to use optical effects to give a kind of a little bit of blowout, a little bit of glow to this moonlight that will be coming in from this upper left-hand corner, and then that will balance out the image a little bit in terms of the balance of it. I have this severe warm light here, I have cool here, but I want to have them a little more in balance. So I'm going to use optical effects to do that. So what I'll do then is I can close this. I'm going to create a point light, and I'll move that point light to be just out of frame and near to that wall. So I can see it's just out and about in the corner there. And immediately I can go in and turn off illuminates by default, because I know that this light, I don't want this light to cast any illumination. I'm using it to kind of mimic a little bit of glare, a little bit of moonlight glare that I just want for aesthetic reasons. So then I will map that light's glow. And you can see I've got my sphere shape here, which serves as the occluder, so I know that this glow will be visible. Scale it up some so I can be sure that I'm getting the right intensity in here. I'm going to go ahead and IPR render this view now. And I can see that point light, I turned off illuminates by default. It's not generating any extra illumination into the scene because I've got my light the way I want it. Now this is not what I want in terms of that light's glow. I want it to be a very, very subtle but very broad wash of blue through here. And that's not it. So, but light glow being IPR tunable, I can just go in and then start designing this light and its glow. So what I want to do is increase the spread probably. Well, first I should pick a region to tune. I can see there's a strange result there. But if I re-pick a region, we can overwrite that and then get this nice glow happening. Who knows, always little things going on. I'm going to bring down the star level because I don't want fine star points unless I had a street light back there or a lamp or a lantern or something back there. This would look appropriate for a lantern, but it's not really the kind of light that I'm looking for. So I'll bring down that star level. And I'll pull the spread back a little, the intensity down, and I'm going to make it a subtle color, some blue, some kind of cyan-y blue, that's in line with the moonlight that I made. I'll pull up that spread a little bit. I'm going to bring back a little bit of star points here, but I'm going to increase the number. I'm going to give a little bit of radial noise and glow noise here. And then again, I'll pull back that star level. And maybe decrease these actually. This down some, and then finally pull the intensity down and the spread up a bit. Intensity again, down some, and I got something more along the lines of what I'm looking for. Up a little, and this is just a tuning thing from now on. Something like that. So there I've got all of these things contributing together. I have mapped light color creating this firelight in here. I have shader glow here creating the illusion that there's something hot in there. And I have an optical effect here simulating the glare of moonlight that I want to get off of this moon, this light that's just out of frame, some glare coming off of it into my eye. And there it is. Gorgeous, yeah? So take a look at this. What we've got here is a scene with a pen of some kind, a jail with some cyborg skulls on the ground, I guess. And what we're doing here is we're using some area lights in the same position as the walls, and they're mapped with the same texture as the walls. So what that's going to do is that's going to create kind of a pseudo bounce global illumination effect. And you can do this, but be aware that anytime you're using area lights, you are effectively increasing the number of lights that you're using in your scene by a bunch, and so you can increase your render times by quite a bit. But we've got the settings here, so that is not too bad in this particular scene. So now if I render this, we can see what we've got. And again, we've got these guys here on the ground. We've got these wall textures, which are baked into the walls. They have some illumination built into them, built into the texture themselves, which you can see here in a second. We've got some hotter points here where the lights will go. Now, the thing to really notice about this scene is that there are supposed to be lights here. There are lights sources there, but you're not able to see the source of the light. So again, you can use optical effects to actually create a visible light source. So we're going to go ahead and do that. Now, what we have to first do is, since these are metallic cyborg heads, we have to first disable ray tracing in our render globals so that we can IPR this scene. Now, if we go ahead and IPR it, we can go ahead and start designing the type of light that we want to be at each one of these points. So I'll pick my region, and I'll pick the light that I want to work on. Get the attribute editor up for that light, and I'll add a light glow to it. Now we've got something there. So now, obviously, right off the bat, we have a visible light source. And we can go ahead and start designing that now. I'll take down the star level a little here, spread up some, a little bit of noise, the intensity up, be a little radial noise frequency here, and that's looking good. I'm going to change the rotation a bit so that it's a little off kilter there, and that's starting to look good. So now we can see that there is some light there actually illuminating this scene. Now the next thing that we want to do is we want to add some shader glow to these skulls here so that they're getting a little bit of glow hit off of them. So I'm going to pick this one, and I'll pick that skull here, get to the material, and I can start to pull up the glow intensity. And you can see it start to come in right there. Now I already have this glow intensity thresholded, and you should know that that is in your rendering editor, multi-lister. There's a shader glow node, and there's a threshold so that it doesn't glow the entire object, of course, but only the brightest points on that object. And it's worth pointing out here that you can only have one shader glow node per scene, so that if for some reason you need to have shader glow with multiple different kinds of attributes, different qualities of shader glow, your only solution really is to render those elements separately and composite them, and to render in passes, because there can only be a single shader glow node per scene. So if we had to have these skulls with a different shader glow quality than some other object in the scene, we would have to composite them. But generally, it's not too much of a problem because, again, your optical effects nodes, those being an effect of the lens through which you're looking, you're usually just looking through a single lens, so you want them to actually be the same. So it's not usually too much of a problem to only have that single shader glow node. However, again, if you need to have two different kinds, your only choice is to composite. So anyway, I've got my shader glow happening on the skulls, a little bit of bloom on those objects, and I've got my optical effect on the light here. Now, what if I want to have each of these three lights sharing the same optical effect node? Well, actually you can share optical effect nodes, but it's a pretty involved process that requires you to use switch nodes and all of this crazy stuff, so it's actually usually much more efficient to create each one of these lights with a separate shader glow node, and then to connect those via the connection editor. Now let's see how to do that. So I'll pick this light, get to its shape, create a light glow node for it, I'll re-pick my IPR region there, and then in the outliner I'm going to uncheck DAG objects only so that I can look at my individual optical effects nodes. My first one, this light, is optical effects 8, and then here I'm going to get the connection editor, and I'm going to reload left, and my new optical effects node, this one, is optical effects 9, and I'll reload right, and from there I can go in and start connecting the attributes that I want connected, and things like the intensity, the spread, star points, rotation, all of the things that I think should be connected up in order to give these two lights in the scene, which should ideally be the same kind of light, the same characteristic, the same quality. Fog noise, glow radial noise, glow noise, and the glow intensity. So now they're starting to look more like each other. And this is a better way for you to share optical effects nodes. So that if I go in and make a change to this light and this optical effects node, I'll be affecting them both. Now, if I go in and do the same for this light, create that light glow node, again, go to the outliner, pick my original optical effects node, and back to the connection editor, reload left, pick my new optical effects node, reload right. Again, you get to these by turning off display DAG objects only. And then picking my region here, I can hook these up in the same way that I hooked up the other ones. And this one is fairly obscured, so I don't need to worry about it too much. But again, you get the idea, and this is how you'll want to share optical effects nodes. So I'm going to go back in, I'm going to turn on ray tracing, and I'll re-render this frame with all of the optical effects nodes in place and shared, so that our identical lights are getting identical treatments in terms of optical effects, and I'm getting shader glow, a little bit of bloom on these metallic looking skulls. So I rendered out a short sequence with a small camera move on this image, and you'll see that since I've rendered out this animation with shader glow auto exposure turned off, we have nice solid shader glow with no popping, none of the popping that you'd normally get if you were to render that with auto exposure on. Solid. And there's that scene with all shader glows, optical effects, and mapping the light color all incorporated into one scene to really push it and make it stand out and make it visually very interesting. Remember, again, using optical effects to indicate where you should have physical light sources, because obviously in Maya, each light that you place casts illumination but does not actually make that light source visible. So again, using optical effects to make light sources visible, the scene incorporates everything we've been talking about. And we've talked a little bit about faking caustics by projecting an image of, and these caustics being representing a water surface that you're looking down through or under. And that seems simple enough because you are faking some caustics that don't necessarily have a distinct caustic generating object. But I'd like to talk a little bit about how you might go about faking a caustic for an object that has a distinct shape, like this wine glass here. And if we do a render of this, we'll see that, well, we have our glass, transparent here, transparent fluid in it. But again, how would we go about getting a caustic to come through this backside and then illuminate on the interior of the shadow? And before I show you exactly how you might go about doing that, in talking about faking caustics in general, even if you have a package that is capable of calculating caustics, and Maya is not by default. However, if you have a version of Maya with Mental Ray, for example, Mental Ray will calculate caustics for you. So you may have the ability to do that, but it's still a good idea to fake, because caustics are, as always, very expensive to calculate. So one thing that you could do is use Mental Ray to calculate out what the caustic should look like, and then employ a method of faking those caustics later on in order to speed up your renders, because it will speed them up dramatically, because calculating caustics is quite expensive. And the good thing about caustics is that they are generally very fuzzy and diffuse, so they're easy to paint maps for what they should look like. So again, faking caustics, even if you have the ability to calculate them, is always a good idea. Now I have here again this picture of this wine glass, and what I did is I went out and photographed a glass of wine here and its shadow and caustic elements here, so you can see what in reality this thing should look like. This is again a photograph of an actual wine glass. These are the caustics through here, and even to a lesser extent this may be the transparency of the glass, but it could be some refocusing of that light through here. And this wine here is quite dense, so we're not getting an overdone caustic. It's very subtle, it's very soft, and this is tremendously easy to paint if you know a good method to go about doing it. So we're going to go over that right now. So let's see how we'd go about faking this caustic. You get Maya up and go ahead and pick the light that's going to, the caustic should be coming from. Of course, in this case, it is the key light. This will be our light that generates the caustics, not the fill or rim, and we can just go ahead and duplicate that light. And it's always good practice to reset your duplicate settings in case you had selected to duplicate input graph or duplicate the input connections for some other operation before, because you don't want to do that in this case. So we duplicate it, we can look through that, which is our new caustic casting light, and then you want to get the attribute editor for this light, and in the light effects folder you want to turn on barn doors, and then you can display camera light manipulator, look through barn doors, and you'll get this little gizmo here, and you can use these to mask off exactly where you are going to cast your caustic, or you're going to cast your bitmap, because what we're going to do is we're going to map light color in order to fake these caustics. So you do a look through barn doors to make this window a little bit bigger, and then you hit the print screen button on the keyboard. There's any number of ways in which you can take a screen grab, but this is the way that I would go about doing it. Hit the print screen button on the keyboard, which will copy this screen into your clipboard. And then when you come back to Photoshop, if you do a File New, you should see width and height of your screen resolution. Click OK and paste that in. And now we have our wireframe here. So we crop this out, and now we know exactly where this light is going to cast its illumination. So that if we resize this, so we can get a little bit more accuracy on it, and I'll create a new layer, and I will essentially just draw around this wine glass here where we should be getting caustic illumination, and I drew a little too much there, so I'll take that off. And now on this second layer, this selection here, I'm going to fill with white. And we'll make another one. Select everything and fill that with black. So now we have a really rough idea of what our caustic could look like. So it's a good idea again to refer to actual real-world reference, and we're seeing that we're not actually getting an entire caustic cast through here. All we're getting are these little effects here, with a little bit of red coming through there, and not even really much caustics from the glass. So you can come up to your caustic layer here and get a color that will be your wine. You could even make a new layer for it. And we can just use a round brush, that's fine. But what I'm going to do is get one that's a little softer here. And then I can go ahead and start to paint some caustic effects here. Get something a little more saturation in there, a little bit smaller. And then just paint something. Again, this can be really loose because caustics are such a soft phenomenon. So this layer that's our glass, we can start brushing out most of it. I'll take the opacity down a little, and you can start to brush most of this out, but leaving a little bit of detail. It'll just be more interesting that way. And then I'll take the opacity down on this wine layer just a touch. And there you have it. So what I'll do is I'll save this out to my project directory. and then I'll come back to Maya. And now our caustic casting light, I'm going to choose to, of course, map its color with a file. And then I'll pick that image that I just painted. And we come back to our perspective view, and you want to be sure to have this light picked, your caustic light, and your geometry that's representing what it's casting the caustics through, and then you want to break the light links from that, because you don't want this caustic light to illuminate this side of your wine glass. And then if I do a render, we can see I'm getting caustics from this. Now, clearly these are in a slightly wrong place, so what we want to do is make sure that they show up correctly. And more than likely what's happened is that my place 2D texture node is incorrect, because I didn't move the light very much, and this looks flipped. And typically that's what happens. So what I'm going to do is get this light again, come back to my caustic projection, I'm going to rotate the frame 180 degrees, and then do a re-render. And there we're getting our caustic image, our caustics through here, through this wine glass, and we may want to brighten them up some. But we're starting to get something that does indeed look like caustics coming through this glass. Now, of course, this is limited by if you had a fluid simulation going on in here and this liquid were moving around, changing shape, the caustics would be caustics of that liquid would be changing shape along with it. So clearly this static image isn't enough, and in order for you to paint a sequence that represented the changing shape of this liquid, it might then be worth it to actually run a caustic simulation on it, because the time you spent, of course, painting that would be you'd spend far more time painting it than you would let the computer calculate the caustics. But in this case, you can get away with painting the map. And if the glass moved, you could certainly parent the light to it and whatever. But again, if you have too much movement in the scene, you're not going to be able to get away with faking it this way. So now I've got another scene here that I'm going to use to bring together everything that we've been talking about. Mapping light color, caustics, shader glow, and optical effects. So I have what is some simple geometry. I've got a palm tree and a little courtyard, and I've got some lights on it. I've set up the lights already, these two spotlights which are illuminating the palm tree. I've got some moonlight coming in, and then I've got some bounce lighting down here from the sky and from the reflected surfaces. But what I'd like to have, I'd like to imagine that there is some water in this little courtyard, a little oasis or something like that. And one way, of course, to suggest water is that it would be reflecting light back up into the scene, which is reflected caustics. So how am I going to do that? Well, obviously I'm going to map a light's color. I'm not going to put a water surface down here, cast a light onto it, calculate out all the genuine, real, true, calculated, reflected caustics just so they can come up and be reflected into the scene here. It would be much more efficient, obviously, to map a light color to it. So what I'll do is I will create a spotlight, move it out to the middle here where it ought to be. I'll rotate it so that it's facing up. the attributes of it. Start with an intensity of 10 because I'm going to use a linear decay because I want it to fall off nicely as it rises up to meet the tops of the buildings. Increase the cone angle so that it spreads over the whole thing. And give it a little penumbra and a little drop off. Now, the next thing, of course, to do is to map it. So use a file texture. I have in here a folder called RGB Cost 3, and I'll pick the first of that image sequence, and you can see the caustic image here. I'll use frame extension, and I'll create our expression. Copy that out. File equals frame extension. File frame extension equals frame. Create it. And then I'll do an IPR render. And you can see our caustics coming in here, and they're interesting, but they are far too sharp. Again, similar to the flames, we're just creating the overall effect of this re-illumination here. It's not projecting caustics out into it as we're doing. It's reflecting off, and then that light gets diffused. So what we want to do is we want to blur this some. And that seems appropriate for what we want to do. And if we re-shade this whole thing, we'll see that we're getting our caustic lighting here looking nice and giving us the clue that yes, there is water down here, without having to do anything else but add this light. So the next area that I'd like to focus on are these lights casting illumination, extra illumination on the palm tree. And what I'd like is for them to, if we look at our last render, we can see, yes, there's a little bulb here with a housing, but it doesn't look like it's lit up in any way. It doesn't look like it's over bright. And if we were really looking at this, we would expect to see some glare coming off this, some kind of blooming off of this that either our eye or the lens was contributing to. So what I've done is I've taken these spotlights here and I duplicated them out to get this point light. And the reason that I did this is if we add optical effects to this light here, if we create light effects, light glow, an optical effect, if we create that on this light and we do a render, you'll soon see that we aren't getting an optical effect on this. And the reason for that is this is a spotlight. So in order to see an optical effect from the spotlight, we would have to be looking directly into the cone of that spotlight, which we're not. So you can see we're not getting that optical effect that we should be getting. And as I've said, it's because we're not looking directly into the cone of this light. So in order to fake this illumination coming off of this visible bulb that we're seeing, as I said, I duplicated this point light to simulate the light, the optical effect coming off it. So I've created an optical effect only light. If I get this spotlight back up, I'll break the optical effect connection and get the outliner here, and we'll concentrate on this point light here, which, as you can see, I've already taken off illuminates by default, changed it to a point light from a spotlight, because as I said, I duplicated that original spotlight, changed it to a point light, turned off illuminates by default, and I turned off the shadows, and now I can add a light glow to it. And then if I IPR render this, we can start to tune it. And that's pretty bright. So I'll pick this. I'll bring down the intensity because, as you can see, the intensity has something to do with the optical effect, the overall brightness of it. And now I can tune this. So I'm going to increase the points, change the rotation a little bit. I'm going to take the star level down, and I'm going to bring the intensity down. And that looks like something that I would expect to see. So the next step would be to get this other spotlight here to share the characteristics of this. So I've already, again, same thing, duplicated this point light out. And if I get the outliner up, turn off DAG objects only, and I can look at my optical effects here. Get the connection editor, and we pick our original optical effect here, reload left, and pick our duplicated optical effect here for our other spotlight, and reload right, and we get the attribute editor up for this optical effect, so I can keep track of the things I've changed and the things that I want to hook up. So I'll want to hook up with between these two lights, between these two optical effects, I want to hook up star points and rotation and glow intensity and glow star level. And that should do it, because I think those are the only changes that I've made to this particular optical effects, to the defaults. So in order to get these to match and share attributes, this should do it. So if I load the IPR for that, we should see these two optical effects being the same, and they are. And the last thing I'd like to do that I think is going to make the scene stand out is I'd like to add a little bit of shader glow to these palm leaves. I think it's going to add a little bit of life to the palm leaves, and if these optical effects are so bright, you would think they would cause a little bit of bloom on these palm leaves, which should be, you know, lifelike leaves or vaguely a little bit translucent, and so a glow can really help these leaves seem as though they are being illuminated by these two very bright lights. So I get the attribute editor up for one of those leaves and the material for those leaves, and in the special effects folder again I can just start bringing up the glow intensity of this material. Pick a slightly smaller area to tune. Doesn't take as long to update. And I can pull this up. And we start to see some of this glow happening. That's a little too much, I'd say. So we've got some glow happening now, some shader glow happening on these leaves. And if I go ahead and render this whole scene, and how about if I pick the right view to render? So we've got everything we've been talking about happening in this single scene. We've got our mapping the light color, we've got caustics, mapping light color is what's giving our caustics, we have optical effects on these two lights here, and we have a shader glow on these leaves. So if we come out here to F-check, I can show you the result of our animation, and you'll be able to get a better look at our animating caustics. It's somewhat hard to tell what's going on with them in just a still, obviously, but now you look at this and you really do believe that you are seeing some water, some light reflecting off some water coming from down here. So hopefully, using these three key techniques that we talked about, you can start to make your images more interesting, more exciting, and just much more beautiful, like this one.